Okay, so today I've got another topic. We're extending our understanding of solving linear equations. This time we're extending it to two-step equations. We call these two-step equations because you must do two separate steps to be able to isolate the variable. Before we do this, I want to just kind of remind you of something here is PEMDAS. We know PEMDAS as our order of operations, parentheses, exponents, multiplication and division, which actually go together, and addition and subtraction, which actually go together. And so when we are solving an equation, what you typically want to do to make it easier is to go in the opposite direction. So what you want to do is start with addition and subtraction first, and then deal with multiplication and division, and then deal with any exponents, and finally clear out what was inside those parentheses at the end. And so using this rule of thumb, if you will, we're going to go ahead and take a look at this first equation. I've got 2x minus 3 is equal to 9. I have two things that must happen here. Underneath the 2 here, you'll notice that I could divide that, and then underneath the 3 here, you'll notice I can add 3 to both sides. So between the choice there, what I want to do is I actually want to add 3 first. Okay, so since I've decided what I want to do, I'm going to go ahead and add 3 to both sides first. This is going to clean this up. So the properties of equality say whatever I do to the left-hand side, I must also do to the right-hand side. So because I added 3 there, I'm also going to add 3 there. Now the very first thing I'm going to do is I'm going to copy down my equal sign. So I'm going to make sure that my equal sign stays in the middle, and I'm going to go ahead and draw myself a line across here, and these two values cancel, the negative 3 plus 3. What I'm left over with is I have a 2x here. I'm going to take 9 plus 3, and I'm going to have 12. My second step, and this is why we call this a two-step equation, my second step is I notice that there is a 2 in front of the x. We actually call this a coefficient. This is 2 times x is what's going on there, even though there's not a multiplication symbol. I could easily put one there. Because this is multiplication, the inverse operation is division, and so I'm going to go ahead and divide both sides by 2. Whatever I do to the left-hand side, I must also do to the right-hand side. Once again, I'm going to begin by copying down my equal sign first. So there's my equal sign, keeping everything in the middle. I'm going to notice that those 2's cancel, and I'm on the left-hand side, I'm only left over with an x. On the right-hand side, I have the number 6. There's your answer. Okay, so for the second example, you'll notice that it's a little bit different here. I have a t that has been divided by 4, and I've had an add plus 8 is equal to 10. So my first step here, obviously, once again, is I want to deal with addition or subtraction first. You'll notice the positive 8 that is there. I can get rid of that positive 8 on the left-hand side by simply subtracting 8. If I subtract 8 on the left-hand side, I also must subtract 8 on the right-hand side. I'm going to go ahead and give myself a line here to separate this work. The very next step that I'm going to do is I'm going to copy down my equal sign. I always like to copy my equal sign first to separate both the left and the right-hand side. I'm going to go ahead and cancel those 8's. They go away. On the left-hand side, I have t divided by 4, and on the right-hand side, 10 minus 8 is going to give me 2. My last step, this is a two-step equation. I've done my first step. I'm going to my second step, is I have t divided by 4, and the inverse operation of division is multiplication. And so I'm going to go ahead and put a 4 up in the numerator. I'm going to put it up top, and if I multiply by 4 on the left-hand side, I also must multiply by 4 on the right-hand side. You will notice here what's going to happen is that those 4's are going to cancel. 4 divided by 4 is 1. Once again, I'm going to go ahead and copy down that equal sign first before I do anything. On the left-hand side, I have isolated the variable t. That was the goal. That's what solve means, is isolate the variable. And I have 2 times 4, which is actually equal to 8. There's my answer. Okay, so for this last example here, I've got a funny looking equation here that has a fraction in front. And so if you take a look at this, the coefficient in front of the y is a 2/3. This isn't going to be any different than the other equations that we've solved. Once again, I first want to get rid of the 1 here. So on the left hand side, I'm going to go ahead and add 1 on the left. I'm going to go ahead and add 1 on the right. I'm going to give myself a big bar here to separate my work. The very first thing that I'm going to do is I'm going to copy down my equal signs. I notice that the 1 and the -1 cancel. Those are gone. That was my goal. I'm going to have 2/3 y on the left-hand side, and on the right-hand side I'm going to have an 8. Now, if you must remember this back from my previous video on solving one-step equations, is the way I can get rid of a 2/3 as a coefficient in front is multiply by the reciprocal. If you remember what reciprocal is, all I'm going to do is I'm going to flip this upside down. I'm going to multiply by 3/2. If I multiply by 3/2 on the left, I also must multiply by 3/2 on the right. The reason why I multiplied by 3/2 is because the 3 can cancel with the 3, and the 2 can cancel with the 2, and what I'm left over is I'm left over with a y equal sign here. Now, what I must deal with is I must deal with this scenario on the right-hand side where I have a whole number times a fraction. And so the first thing that I'm going to do is I'm going to go ahead and put that in 8/1, which will allow me to multiply this out. 8 times 3 is going to give me 24, all divided by 1 times 2, which is going to give me 2. Your last step is to reduce this if possible, and in this scenario I'm going to end up with y is equal to 12. And so that there is my final answer. Okay, so this last part here is actually, I just want to show you one last example. I know I said the last one was the final one, but I just thought of the scenario here. I wanted to take a look and show you here how I can rewrite the exact same problem 4 different ways. And so what I hope you recognize here is that these are actually all the same problem. I'm going to solve these all together at the same time. And so the first problem, I've got 5x minus 1 is equal to 14. The x is on the left hand side, therefore I want to get rid of the 1. I'm going to go ahead and add 1 on the left, and I'm going to go ahead and add 1 on the right. That's going to go ahead and give me my first step. On the second equation over here off to the right, you'll notice that the x is here, and there's also a positive 1. That means I'm going to go ahead and add 1 on the right. Whatever I do to the right, I must also do to the left-hand side. That's all going to be the same thing. I can also rewrite this where I actually put the -1 first. So instead of writing 5x minus 1, I actually wrote -1 plus 5x. This still requires me to do the exact same work where I'm going to add 1 to both sides of the equation. Lastly, I can rewrite this where the 14 is on the left-hand side and the -1 plus 5x is on the right. I'm going to go ahead and once again, I'm going to add 1 to both sides here. This first step is going to end up with, in the top here, I'm going to end up with a 5x is all equal to 15. In this scenario, I'm going to end up with a 15 on the left-hand side, but on the right-hand side, I'm still going to have a 5x. In this lower left-hand corner, I'm going to have a 5x on the left, and I'm going to end up with a 15 here. And lastly, I'm going to end up with a 15 on the left-hand side, and I'm going to end up with a 5x on the right. All of these, the next step for all of these are exactly the same. What we're going to do is we're going to divide each one of them by 5. It doesn't matter whether or not the x is on the left-hand side of the equation or the right. I can solve these either way by dividing by 5. Divide by 5 on the left, I divide by 5 on the right. I divide by 5 on the right, and I divide by 5 on the left. Divide by 5 and divide by 5. I hope you recognize that these all are the same equations. What's going to happen with all of these here is that these are all going to cancel, and every single one of these is going to give me a value of x is equal to 3. Now the 3 may be on the left or may be on the right hand side, but hopefully you recognize that all 4 of those are the same scenario. I hope this video helped you out, and I hope you have a wonderful day.